The back half of Chapter 2 really centers on nomenclature and characteristics for bonding, both molecular and ionic compounds, which is what we touched on Chapter 1. So, getting right into it, molecular compounds, again, two or more nonmetals. Covalent bonds form when atoms share one or more electron pairs. One pair is a single bond, two pairs double bond, three pairs triple bond. I'm never going to ask you how many electron pairs are part of a bond. That's just something that I expect that you have the intuition to just conclude. So charged particles form, right, when electrons are added or removed from a neutral atom or molecule. The charge is indicated by a superscript, right? Removing an electron leaves a positive charge. We write that as a plus. If it's 2 plus, so 2 electrons were removed, we write it as 2 plus. If 3 electrons were removed, we write it as 3 plus, right? If we added an electron, we write it as minus. If we added 2 electrons, it's 2 minus, 3 minus, etc. Okay. We can predict charges for ions based on where they are in the periodic table. So if you have your periodic table handy, pulling that out right now might be a good plan. Metals are our positive ions or our cations. Our nonmetals are our anions. And we'll zoom in on this right here. So group 1, right? Recall. Group 1, group 2, group 3, metal, 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 right? So group 1 only needs to lose 1 electron to have a noble gas configuration. So it'll have a +1 charge. And just saying plus or 1 plus. I'll write 1 plus even. Here, let me write that a little bit more separately so it doesn't look like an H. Or 1 plus. Group 2 will tend to have a 2 plus charge. So if you have a beryllium, magnesium, calcium, strontium, it's 2 plus. Group 13 or group 3 will have a 3 plus charge. So aluminum, gallium, indium, thallium will have a 3 plus charge. If you're in group 15, so you're nitrogen, phosphorus, arsenic, etc. Oh, excuse me. Sorry. No, that's right. Sorry. So sometimes we instructors do make mistakes. I apologize. I was subconsciously counting the noble gases as a group that I was talking about. I'm not talking about the noble gases. Group 15, nitrogen, phosphorus, arsenic, antimony, things like that, will tend to have a 3 minus charge. Atoms in group 16, oxygen, sulfur, selenium, beryllium, will have a 2 minus charge, while our halogens, fluorine, chlorine, bromine, iodine, will have a 1 minus charge. Or just, here, I'll write it in the same format. Minus or 1 minus. Right? Now, when we're naming these things, obviously everyone's heard of table salt. We've all talked about sodium chloride before. We have acted like we were, woo. You heard it in elementary school, middle school, high school. So we've all heard of sodium chloride, right? So how do we get sodium chloride? So when we talk about ionic compounds and we're naming it, we always name it cation first, anion second, right? The cation, you just say the name of the metal. The anion, it depends. So situation 1, you could just have, right, an element with negative charge. Right? Chop off ending. Add IDE. Example. Chlorine. Chop off that INE. Here, I'll do it in red. And that goes to chloride. Right? Another example. Oxygen. Chop that back part off. We get oxide. Right? So keep just the prefix. Right? Keep prefix, actually. I'm going to actually rewrite this. Hold on. Keep prefix. Change suffix to IDE. Right? Or 2, we can have a polyatomic ion. which you will name later. So let's go back to this table here, right? For sodium, remember we said that that was just a +1 or just a plus. Chlorine was just a minus. So the ionic compound is NaCl, or sodium chloride. Right. Calcium is a 2+, oxygen is a 2-, right? So we can say it's just CaO, or calcium oxide. Cool, right? So now remember how we said that it was a whole number ratio of elements, right? They arrange themselves in ratios where the charge is neutral in ionic compounds, right? So aluminum, as we set up here, it's group 13, so aluminum has a 3+ charge. But bromine is a halogen. Okay, it only has a -1 charge. So we need to know how many bromines do we need to even out that big 3+ charge that aluminum offers. And it turns out that we need 3, right? Because 3 bromines make 3- charge total. That cancels out the 3+ charge. So we write this as AlBr3. And I don't really want the Br to look like a beta. And that is aluminum bromide. 2 more examples. I'd like you to pause the video and try to do these 2 on yourself, Wow. Do these 2 on your own and see if you can come up with the answers yourself. So let's tackle these last 2. Magnesium is a 2+, and I'm going to do these a little faster because I'm assuming you've done these already. Fluorine's a -1, so we need MgF2, and that's magnesium fluoride. Also notice that fluoride is UOR. It's fluoride, not fluoride, so do not ever say fluoride, right? Potassium's a +1, sulfur is a 2-, so we need K2S because we need 2 of the potassiums, and it is potassium sulfide. All right, potassium sulfide. On to the next page. Super fun, right? So we get to now use these things called prefixes. So throw that IDE stuff, or actually you're going to keep the IDE stuff. Wow, I chose the wrong thing. So now rather than just naming the ion, you're just going to tell me how much of each thing you had. Okay? So we're going to use these prefixes, read the ones that are right here. I'm not going to take a bunch of time to read them all to you. Read those, pause the video if you need to, right? So P2O5, right, there's 2 of the phosphorus, so it's diphosphorus pentoxide because there's 5 oxides. Okay. This first one, there's 1 carbon, but right, do I write mono here? I do not write mono here, right? So if it's the first species and there's only 1, you just leave it, right? So this would be carbon, I'll do the same color, carbon tetrafluoride. All right, again, there's 1 nitrogen. I don't need to write mononitrogen, but I do need to write triiodide. Nitrogen triiodide is actually really explosive, so that's a lot of fun. Google that. Again, there's 1 carbon at the front, so I don't say monocarbon, but I do have to say carbon monoxide. Now, pause. Come back a couple steps. Monoxide really doesn't sound right, right? So where we have species where they start with a vowel, drop that vowel out of your prefix. So carbon monoxide. So we drop the O just to make it a little bit easier to say. Right? So now we're going to write the formula from the name. Right? Dinitrogen tells us there's 2. Tetroxide tells me there's 4 oxygens. So N2O4. Phosphorus tribromide, that tells me there's 1 phosphorus, right? Because there could be a mono right there, right? But we don't write that. we just leave it, right? So PBr3. Try these next two by yourself really quick. Pausing the video. So we're back. Now let's do these last two, right? Sulfur hexafluoride, so there's no mono there, but it means there's one, so FSF, so fluoride, and then hexa means there's 6, SF6. And then oxygen difluoride, right? Mono oxygen, we don't write that, so it's just OF2. OF2. Right? Now, there are some molecular compounds that have common names, so it turns out, right? Water being H2O, methane CH4. If you use Bunsen burners, that's the gas that goes through there. I'm going to say this now. I'm just going to say it, and I'm going to hope you remember it. Every good chemistry student knows that ammonia is a weak base. Just know that. You don't need to know what that means yet. Just ammonia, NH3, weak base. It'll come back. I promise I will say it in another video in Chapter 4. Right? So, right, we already really kind of talked about how to name ionic compounds. By the way, there is one polyatomic cation you need to know, NH4+, which is the ammonium cation. Right? Every other cation you need to know is a metal. You will just be able to read it. Right? Now, when we write the metal, right, when we say sodium chloride, we know that sodium is always going to be a +1 charge. It's in group 1. It loses 1 electron to be the electron configuration for neon. Noble gas configuration means stability. And sodium has a +1 charge. However, there are some elements that have more than one possible charge, and we call those transition metals. Okay, so we wrote down what transition metals were back in the other notes video, so take a look back at that if you want. But for example, instead of sodium chloride, what if we had copper chloride? Right? If we had copper chloride and we needed to write the formula from that, we wouldn't really know which charge copper was. Okay? Some inside information for you. Copper has 2 common oxidation states or charges, +1 and +2. Right? So to indicate which oxidation state of copper we have, we place the charge of the transition metal in Roman numerals next to the transition metal name. So directly after the transition metal name, but before the anion, right? So if we had, let's erase this. If we had CuCl2, we would know it's copper 2 chloride, right? If we had CuCl, it'd be copper 1 chloride, right? And we know this, right, because chloride is always a -1, that chlorine's a halogen, it's always a charge of -1 when it's an ion. If there's 2 of them, then the copper has to be a +2 charge. If there's 1 of them, that means the copper has to be a +1 charge, right? So this is always talking about the charge of the transition metal. Cool. So next page. There was an old system of naming things, and there's a little chart here that will help you out to figure out kind of common charges and trends. And I implore you to read that yourself, to be honest. So pause the video, take the time you need to read that, and take a break, honestly, if you need one. And I'm going to keep on trucking with naming anions. We're going to get into polyatomic anions in just a bit, but feel free to take a short break. And looking at all these things, I will not be asking you about Latin suffixes. There are a bunch of trends for naming anions. For monoatomic anions, just remember you just chop off, you keep the prefix and change the suffix to "ide." So fluorine as a negative anion would be fluoride. Chlorine as a negative anion would be chloride. I guess I don't have to say negative anion. If we have sulfur, of course, it'd be sulfide. Bromine would be bromide. Now you'll learn some more anions. A really, really popular one is hydroxide, OH minus. Another popular one is peroxide. You've heard of hydrogen peroxide, H2O2, right? Hydrogen peroxide. When nitrogen's an anion, or three nitrogens together is an anion, it is azide. And when a carbon and nitrogen are triple bonded to each other, it is called cyanide. Polyatomic anions tend to have that ATE ending. If there are two polyatomic anions with common starting materials, for example, in this example down here, SO4 2- and SO3 2-, right? The anion with the larger number of oxygens, or the larger oxyanion, as we can say, or oxoanion, excuse me. I have it typed correctly, but I can't read. That's great. Will the larger number of oxygens will have the ATE ending, the lower number of oxygens will have the ITE ending. Also, if there are more than two and there are four, even less oxygens than that with the ITE ending will have a hypo, HYPO, in front of it, much like sodium hypochlorite, the active ingredient in bleach. And another example would be if it has more oxygens than the anion with the ATE ending, there will actually be a PER, P-E-R dash, or P-E-R. Well, the dash indicates that it's a prefix, but P-E-R in front of the anion, so pay attention to that. So in this case, right, we have sulfate and sulfite, right? NO3 is nitrate, NO2 is nitrite. And I encourage you to look on the Chapter 2 notes page. There will be a list of polyatomic anions that you need to memorize. Yes, memorize. Because the tests from Chapter 2 will probably be timed. Actually, they will be timed. And there will be a separate quiz on Chapter 2 that is exclusively nomenclature. Or I will work it into the Chapter 2 quiz. That will be just naming questions, and it will be timed, so you won't have time to look all of this up. Okay, memorizing these is super, super important. For the students that I lecture actually in person, this is something that I always do when I'm doing review with them, is I will address something before I actually have to do it. So, again, per means more and hypo means less, as I explained. So remember, even more oxygens than that anion with the ATE ending gets the per. Even less oxygens, even less oxygens than the ITE ending gets the hypo. Hypochlorite. Don't worry about this note down here. So, we're going to finish up this last page of notes, right? And then there's going to be a page of practice problems that you guys can do at the end that's really going to help you prepare for the quiz. So we're hoping to keep this under 25 minutes. So some oxoanions with -2 or -3 charges will combine with hydrogen to produce other anions, right? So this can produce a hydrogen anion or a bianion, right? So everyone's heard of sodium bicarbonate, baking soda, right? So that HCO3- is the anion. So if we had sodium bicarbonate, it'd just be NaHCO3, right? And the HCO3 has a -1, Na has a +1, so we're good, right? We can do the same thing with sulfates, right? So we can have HSO4- or 1-, which is hydrogen sulfate or bisulfate. We can do the same thing with SO3-, hydrogen sulfite, or bisulfite. So, determining the charge on each ion is actually based upon the name in some cases, but you will need to determine the formula from the name as well as the name from the formula, so you have to go both ways. Calcium sulfate involves calcium and sulfate. Big shocker, right? Lead 4 oxide involves lead, but make sure that it's the 4+ oxidation state, not the 2+, right? And then oxide is O2-. right? And ammonium acetate involves ammonium. Remember, the only polyatomic cation you need to know, and acetate, which is CH3COO-. And that was actually listed on the previous page. Right? So, since calcium is 2+ and sulfate's 2-, 1 calcium is to 1 sulfate, the charges balance out to give me CaSO4. Calcium sulfate. Right? And the next one, we're just going to have 1 lead 4+ to 2 O2-, so we can balance out that 4+ with 4-. So we have PbO2, lead 4 oxide. And we have, right, 1 NH4+ to 1 CH3COO-, so that is just NH4 CH3COO, ammonium acetate. So, another technique that you can use is called the crisscross technique. Once you've been doing this long enough, this will just be so easy to you. So do yourself a favor, let's pause the video for a second so you can try this by yourself, and I will work through these next examples in a couple seconds. Pause that video. Okay, so hopefully you paused the video and did the questions. I'm going to go through it quickly just to see, so you can check and see if you got it right. Magnesium chloride involves magnesium 2+ and Cl- to give you MgCl2. Potassium carbonate, you have K+ and CO3 2- to give you K2CO3. Barium sulfide, right? For barium sulfide, you will have Ba2+ and S2-, so you will have BaS. Cool. Actually, that looks terrible. BaS. There we go. When there's more than one of a polyatomic anion in a formula, put parentheses around it and the subscript outside. So, do not write subscripts without parentheses, because then you just have a lot of your last atom, right? They're polyatomic, so it applies just to that last one. So ammonium carbonate has NH4+ and CO3 2-. So I need NH4, and I need 2 of those to go along with my CO3. All right, so parentheses around the thing I need more of, 2 around the whole thing, so I'm multiplying the entire thing by 2. You do not put them as coefficients, you write them as subscripts. All right, if we have iron 3 hydroxide, we have iron 3, and we have hydroxide, right? So it would be FeOH3. And last one, aluminum sulfate. So we'd have Al3+, we had SO4 2-, and we would have Al2 SO4 3. Aluminum sulfate. Last little bit, hydrates are something else that we involve ourselves with. Hydrates just mean you're going to put a dot, like a multiplying sign, and then however many hydrates the prefix tells you, right? So, for example, this calcium sulfate dihydrate is CaSO4 calcium sulfate times 2H2O, right? So that's how you'll do it. If we had, copper 2 chloride pentahydrate, copper 2 chloride right, it'd be CuCl2 times 5H2O. So use that prefix. That's your number of waters. So there are practice problems listed on the next page. The answers are down here if you need them. But awesome work, you guys, on finishing Chapter 2. I look forward to seeing your super successful quiz results and using these practice problems to your advantage to get ready for the assessment. And I will see you in Chapter 3. So, best of luck.